Today we're going to have a look at fractions and see what they look like, what they're made up of, and try to understand them a little bit better. So I'm going to write down 3 ways in which a fraction could be represented to us. We could have 2 over 3, which we can read as 2/3. We could have 7 over 5, and as a third example, let's take 2 3/4. So in these 2 fractions, we can see that we've got a number over a number, a number over a number. So the top numbers have been given a name, and the bottom numbers have also been given a name. And the top numbers are called the numerator, and the bottom number is called the denominator. And you'll notice that while I was writing those 2 words down, I was actually saying the syllables out loud. And if you want to get a very long word with many syllables spelled correctly, it's a good idea to do that in your head. Just break it up into syllables, and you're more likely to be able to get the spelling correct. So let's have a look at what these 2 are actually meaning. They've got a numerator over a denominator, and what this actually means in this situation is, and I like to teach with pizzas, say for instance you had a pizza. If you were going to eat 2/3 of the pizza, then it would mean first of all that you had to cut the pizza into 3 slices. So the denominator tells you how many slices or how many pieces, and they need to be equal pieces. I'm not sure how accurate my drawing is going to be, but we're going to pretend that they're equal pieces. So I have a pizza. It's been cut into the number of slices that the denominator is telling me. I then look at my numerator, and that is telling me that I ate, or I shaded in, 2 of the slices. So diagrammatically, that's what 2/3 or 2 over 3 looks like. Denominator tells me how many slices. Numerators tell me how many I ate. So the difference between this type of fraction and that type of fraction, you've probably noticed already, is that the numerator here is smaller than the denominator, and here the numerator is larger than the denominator. When the numerator is smaller than the denominator, you'll notice that diagrammatically I didn't manage to eat the whole pizza. So this represents part of a whole. It's less than a whole when the numerator is smaller than the denominator. However, when the numerator is larger, it represents something that is greater than a whole. So imagine I was in a pizza eating competition and I had quite a few pizzas put down in front of me. This number here in the denominator would tell me how many slices each pizza was cut into. So what happens is I start eating, and I manage to eat all 5 of my first pizza, all 5 slices of my first pizza. In other words, I've eaten a whole pizza. And then I go on to eat 2 more slices from the second pizza. So you can see that I've eaten all of the first one, part of the second one. This definitely represents something which is greater than 1 whole. So let's get on to this one, because these 2 are actually quite closely linked. We've already seen that represents more than 1, and here we can see that it represents more than 1 because it's saying 2 3/4. So this one, this type of fraction, is called a mixed number, and some people call it a mixed fraction. The reason it's called mixed number or mixed fraction is because it's made up of a whole number part and a fraction part, so it's a mixture of the 2. This one, where the numerator is smaller than the denominator, is called a common fraction, or some people call it a proper fraction. And remember, that one represents part of a whole, less than a whole. This one, where the numerator is larger than the denominator, is called an improper fraction, and that does not represent something less than a whole. It represents something more than one whole. Okay, so these two, because they both represent something greater than a whole, they can be interchanged with each other. So you could write something as an improper fraction or as a mixed number and have it mean the same thing. So they would have the equivalent value, but they would just be written in a different form. So let's start with this one. Let's do this one over here, 7/5. Now we have to remember that this little line here of a fraction actually means division. So 7/5 is actually saying 7 divided by 5. And if we're trying to change that to have that kind of form where it's going to have a whole number and then a fraction attached to it, what we need to do is exactly what this operation is telling us. So 7 divided by 5, the easiest way to work that out is to say how many times can 5 go into 7. Well, if you count in fives, 5, 10, no, you've gone too far, so you need to go back. It only goes in once. When you counted in fives, you got up to 5. So now you've got to work out how many are left over. What is the remainder? You got up to 5. Count on to 7, 5, 6, 7. I've got a remainder of 2, and the denominator stays the same. So 7, if I eat 7/5 of a pizza, it actually means I ate 1 whole pizza and 2/5 of the next, which we kind of discussed up there just now. Let's take another example. Let's take 15/4. So 15/4 actually means 15 divided by 4. So I'm doing this the slow process because there's so many children these days that don't know their tables very well. So for those who don't know them very well, 2 things. First of all, I would encourage you to learn them better, and the only way to do that is to practice, practice, practice. But if you are a little bit wobbly with your tables, then the best thing is to count in this number, but you're not allowed to go past that number. So we're going to go 4, 8, 12, 16. I've gone past that number, so I put that finger back. 4, 8, 12. 4 can go into 15 3 times. Then I've got to remember that I've got up to 12, so I've got to count on from that number. 12, 13, 14, 15. So there are 3 left over, and my denominator will stay the same as what it was. So when you're converting from an improper fraction into a mixed number, you're simply remembering that this little line here means divide, and that's what you do. So let's have a look at converting a mixed number into an improper fraction. So let's take the one that we've got first of all, 2 3/4. So the way to remember to do this one is you're going to multiply the denominator by the whole number, and then the answer you get, you're going to add on the numerator. All right, so it's almost like working in a circle. Multiply that by that, get the answer, and add the numerator onto the answer. So we're going to say 4 times 2 is 8. 8 plus 3 is 11 over whatever was the denominator stays the same. So what's really nice in converting this way and converting the other way, denominators always stay the same, and you only have to remember the rest of the trick. So let's take 3 7/9. Let's test the tables a little bit more. You don't need to keep doing this every time. You might want to do this with your pencil to start off with, just so that you get used to the process. But eventually you're not going to have time to write all those little loops and things in. You just need to start to remember. So 9 times 3 is 27. 27 plus 7 is 34 over whatever my denominator was. And that is the basics for fractions. If you can understand all of this, then you'll be able to go on to the next videos, which are going to teach us to add, subtract, multiply, and divide fractions. I look forward to seeing you then.